Welcome to Bald Spot Math. Today we're going to be talking about distance. Distance is one of those concepts that it's always positive. There are no negative distances. Yes, I can walk backwards 3 feet, but it's still, I say I'm walking back 3 feet, not I walked negative 3 feet. Distance is always positive. And of course, there's multiple ways to measure distance. There's feet, inches, yards, meters, kilometers, all sorts of measurements for distance. Today we're going to focus on what that means for a coordinate plane. Let's take a look. Alright, so measuring distance between points on a coordinate plane. And if you don't know what a coordinate plane is, I'm going to have an example up here in a minute. But you really should at this point know what a coordinate plane is. So, number one, if a line formed by connecting the points is parallel to the x or y axis, remember the x-axis is horizontal, parallel to the floor. The y-axis is vertical, perpendicular to the floor. But if the line formed by connecting the points is parallel to the x or y-axis, then you can count the spaces between the points. That's one way to do it when you're working with a coordinate plane. If the line is parallel to the x or y-axis, you can also do some simple calculations. If the points are on the same side of the axes, meaning they don't cross over the y-axis or the x-axis, all right, you can subtract the absolute values of the points, and I'll show you an example of that. And if the points are on different sides of the axis, add the absolute values. All right, so let's take a look, first of all, at a coordinate plane with some points on it. And here we go. So I have a point 4, 2 and a point 4, negative 2. And to calculate the distance, I can use my finger and do some counting because these are running parallel to the y-axis. So it's very simple for me to see that it's 1, 2, 3, 4 units apart, whatever these units might be. However, I can also talk and do what I talked about here. These are crossing over the x-axis. They're on different sides. All right? So, if they're on different sides of the axis, add the absolute values. Well, since I'm going up and down, I'm going to use the y-coordinate. And this value is a 2, so I'm going to add the absolute value of 2, which of course is 2. And I'm going to add the absolute value of negative 2. And if you don't know, these parallel straight lines mean absolute value. So this is the same as 2 plus 2. And they're 4 apart. Let's keep going. So once you know the distance between points, you can calculate the perimeter and area figures. Well, I'm going to just look at the area today, okay? And let's take a look at a figure I've drawn. Well, I haven't drawn it yet. So I need my lines. And I'm going to connect my lines. Oh, I did draw it. It's just very light for you to see. Ooh. Okay, so I have my box, my rectangle. I've got my points. So I've got to calculate the distance. And again, I can do counting. But for now, I'm going to do the adding or subtracting of absolute values. And what you'll notice in each of these cases, I am crossing axes. So, going up and down here, I'm going to take the absolute value of 4, and I'm going to add the absolute value of 2, and I'm going to get 4 plus 2, which is 6. So this is 6 units. I don't have to do that here because these are parallel and congruent. That's one of the definitions of a rectangle. All right, now I'm going to go across this way. Now I have to look at the x coordinates of each, and I'm going to take the absolute value of negative 2, and I'm going to add that to the absolute value of 7, and I'm going to get 2 plus 7, and that's 9 units, and of course, this is also 9. So if I were doing the perimeter, I would simply have to add up all these sides. 9 plus 9 plus 6 plus 6. To do the area, we know that's length times width. which is the same as 9 times 6, which is the same as 54 units squared. And that's how you can use distance and measurements on a coordinate plane.